Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about FIR ideal high pass filter design. So given problem is design an ideal high pass filter with the frequency response of h of e power j omega will be equal to 1 for the range of frequency pi by 4 less than equal to modulus of omega less than equal to pi. That means you have mentioned as a modulus of omega, it indicates that it will be for a range of frequency pi by 4 to pi, also minus pi by 4 to minus 5. And that will be 0 for modulus of omega less than equal to pi by 4. That means it indicates both cases, that is 0 to pi by 4 and then 0 to minus pi by 4, this value will be 0. Also they given that we need to find a h of n for n value is 11, that is the filter order is 11, we need to find the 11 samples. So also find h of z and then we need to plot the magnitude response. First take the question, so first plot it. So we take this value from pi by 4 to pi, this value will be 1. Also minus pi by 4 to minus pi, the value will be 1. Look at the graph, so plus pi by 4 to plus pi, this value will be 1 here. Look at this, I am putting here as 1.0, this is 1. So from the range from pi by 4 to pi. Similarly, minus pi by 4 to minus pi, this value will be also equal to 1. And that will be 0 for modulus of omega less than equal to pi by 4. So from 0 to pi by 4 the value is 0. Similarly 0 to minus pi by 4 the value is 0. Now the total integral is minus pi to plus pi. Now it becomes 2 integral. So one is from pi by 4 to pi, this is one integral. And another one integral is minus pi by 4 to minus 5. So now we need to split it into 2 integrals. So look at this. So h d of n is the given formula is 1 by 2 pi integral of minus pi to plus pi h d of e power j omega into e power j omega n into d omega. So we know the value for h d of e power j omega, we can substitute and then we can split the values because from pi by 4 to minus pi by 4 the value is 0. So I am taking this 1 by 2 pi integral of minus pi to minus pi by 4. So this is for first integral. So minus pi to minus pi 4. So look at this, minus pi to minus pi by 4. So h d of e power j omega is 1. So 1 into e power j omega n into d omega. So that's why I am taking say e power j omega n into d omega plus. So next integral is plus pi by 4 to plus pi. Look at this. So this is plus pi by 4 up to this pi. So again h d of e power j omega value will be 1. So 1 into e power j omega n into d omega. Now we need to integrate this and we need to substitute a upper and lower limit. So we take this 1 by 2 by common and then we integrate this value. So e power j omega n into d omega. If you integrate it, you get same e power j omega n. Also, we need to differentiate this value because this is a function of function. So if you differentiate it, so e power j omega n into d omega. So we differentiating with respect to omega, so we get a jn. So we need to put it as a denominator. That's why I am taking a common as jn here. So 1 by 2 pi jn. Again that e power j omega n upper limit is and lower limit is, this is minus pi and this is minus pi by 4. Similarly for this also we get the same thing, e power j omega n into d omega, we get the same e power j omega n. If you differentiate it, you get a denominator as jn. So that j1 is common for this term also. So we need to substitute this e power j omega n into upper and lower limit, that is plus pi and plus pi by 4. So if you substitute it, look at this 1 by 2 pi n pi we have it. So we need to substitute upper limit minus lower limit. So upper limit is e power minus j pi n divided by 4 minus e power minus j pi n. This is upper and lower limit for first integral. For second integral, so e power j pi n minus e power minus j n pi by 4. So here I am going to combine these two terms with respect to the same form. So I can combine this term and this term. Similarly these two terms. So if you combine these two terms, look at this e power j n pi minus e power minus j n pi. So this is e power j theta minus e power minus j theta form we have. So we can combine it. Look at these two terms. So minus e power minus n pi by 4. Here is e power minus n pi j by 4. So if you combine these two terms, we have find that minus e power plus j theta plus e power minus j theta available. So instead of that we take a common minus. So once if we take a common minus, it becomes e power n j pi by 4 minus e power minus j n pi by 4. So it will be similar to that sign form. So we can combine it. That's why I am taking this 2j also with this. So remaining we have 1 divided by n pi and then sine of n pi for these two terms. This is the internal two terms, and minus sine pi by 4 by n. This is for this term and last term. We are combining it because we know that e power j theta minus e power minus j theta divided by 2j will be equal to sine j theta. So using the same formula I am computing this. Now we need to truncate this for an 11 sample. So hd of n will be truncated into 11 samples. So h of n equal to hd of n for modulus of n less than equal to 5. That means minus 5 to plus 5, the value is hd of n, and that will be 0 for remaining samples. That is, I am finding this h of n and then truncating the remaining all samples. I am taking only minus 5 to plus 5 samples. Remaining samples will be put as 0. It's called as truncating. Thank you.